Hey, this is Mr. Mailhot for some pre-calculus. I got my friend Jason here.
Hello, Jason Vasquez Romero, the
right.
GOAT.
Oh, goodness. All right. We're going to go through a couple of homework problems that I assigned you guys. Remember, we're dealing with polynomial functions and the end behavior and things like that. So let's do this box here.
All right.
So it's asking, for each of these graphs, describe the end behavior. Is it an even or odd degree function and the sign of the leading coefficient? So let's knock out A first. End behavior. For end behavior, Jason, you remember how it's always written, like the first part of that sentence?
No, I don't remember.
Okay.
But
What do you remember?
we in my pre-calculus class, we put x equals as f of x equals.
Close, super close.
Yeah. That one.
So these are basically like sentences. And actually, you can tell I'm doing it while I'm talking. Like, you don't have to think. This is always the start of your answer. So as x, I forgot some stuff though. Maybe you can't do it while you're talking. As x goes to positive infinity, and as x goes to negative infinity.
Yeah.
So we want to know what happens when we go that way, and what happens when we go that way. What do you think?
Well, we're gonna go up to infinity because it's going up and it's positive.
The graph's going up? Okay.
Yeah.
So up towards positive infinity. So as we're going this way, the graph is going up. Good.
Yeah. And then as we're going down negative, we're going down in the negative direction.
Yeah.
So you're going to get a negative infinity.
Perfect. So as we go in the x direction in this negative way, the graph continues down. Goes to negative infinity. Okay, B asked for, is the graph an even degree or odd degree? Okay, don't get this confused with even function versus odd function, right? It's not, obviously it's not symmetrical, like it's not an even function.
So it's asking whether it's like the power of something, even if it's
the highest exponent. Yeah. What do you think? Is the highest exponent going to be even or odd?
Odd.
How do you know that?
Because they're facing the different directions. From each other.
Think about the O's. Odd, they're opposite directions. O's. See, the sign of the leading coefficient, that means is it positive or negative?
It's positive.
How do you know?
Because it's going in a positive direction. So if like there was a linear line right here, this would be positive.
Oh.
Yeah. See?
I hadn't thought of it that way.
You always have to think of it.
That would work, yeah. I guess if you could connect the arrows, I guess.
Yeah.
Like that would be a positive slope. That works. Yeah, I like that. I might have to tell my kids that. Positive. All right, let's do the next one.
All right.
So, same start. As x goes to positive infinity and as x goes to negative infinity, what's happening?
They both go down negative infinity because the leading coefficient is negative.
Oh, how do you know the leading coefficient was negative?
Because it's going the opposite direction it should be.
Then it should, what do you mean it should
Like,
be?
if it was positive, it'd be going down negative. Like, no, if it was positive, it'd be going up.
Like this?
Yeah, exactly.
Okay. But since both of them are going down,
it's negative.
so this last one we know you're thinking it's negative.
Yeah, negative. And it's even because they're both facing the same direction.
Same direction, right?
Yeah.
Same direction if they're both going positive or they're both going negative.
Yep.
Even. So it could be, it for sure can't be a 2, right? The degree can't be 2.
No, it's a 4.
It's a 4.
1, 2, 3, 4.
Because it's got 4 roots.
Yeah.
Okay, all right. Question 3. Describe the end behavior of a 14th degree polynomial. So that means like it'd be something x to the 14th with a positive leading coefficient.
So like a 2.
Sure. So if we had like 2x to the 14th plus a bunch of other junk,
Okay.
what would the end behavior be like?
Positive.
How do you, so describe, or you can sketch on there if you want.
All right, so since it says positive leading coefficient, it's going to go in the positive way. And since it's an even degree, it's going to go, both of the ends are going to face the same direction.
Okay.
So they're both going to go up.
I like to look at it like this. Like, you know, like what you just said, you know the ends are going to go up because it's positive.
Yeah.
And they're going to go the same direction because they're even.
Yeah.
But, like, who knows what could go on in the middle?
Yeah.
Okay. cool. I guess this is good enough to describe. We could do it this way. As x goes to infinity, f of x would go to infinity,
Yeah.
and as it goes to negative infinity, it would also go to
Infinity.
yeah. Okay. This one, 9th degree with a negative coefficient. So negative something times x to the 9th would be the largest term.
-3.
Sure.
But
Sure, we can put a 3 there.
it's gonna be negative because it's a negative leading coefficient, and they're gonna be facing opposite directions since it's an odd degree.
Okay.
So it's gonna be like this, and then another one like that, and then whatever goes on in the middle.
Yeah, because I like that what you did up here, because like the slope between those would be negative. So if we had to write it out our nice way, as x goes to infinity and negative infinity, the graph. Well, actually, this is a pretty good. We can use this. We can use that picture to tell us our answer, right? As we go out towards, like if this was the axis right there, as we go out towards positive,
it goes negative infinity, and then it positive.
Yeah. You notice the pattern that when it's an odd degree, these behaviors are opposite.
Yeah.
Right.
No,
Odd,
opposite of each other.
and they switch.
Yeah.
Cool. All right. Can you finish my saying? We're mathematicians.
We're lazy perfectionists.
Okay. Yeah. But we can also do anything we want.
Yeah.
All right. Nice job.
Thank you.